So I thought I should make a better recording of this. This is going to be a look at the motor shield and how to make it go. And fortunately, there is a very good tutorial on a clone of this motor shield at Adafruit, and you can go through the tutorial. But we're going to just look at the code that Adafruit produced and go from there. That's my code. And here is the Adafruit code. At the top you have some comments. It says it's in the public domain. Enjoy. This right here says include this file in the program when you load it to the Arduino. Include this library called AF Motor. And this is Adafruit Motor. And so that's the MotorShield library I told you to load up. Servo is a built-in library, and that's why it's got this orange color. And so if you load those both up, then some things can happen for you, and you can use some tools that are available. One of these tools is called Adafruit DC motor, and this allows you to hook up a motor to the port on the motor shield labeled 2. So you hook up a DC motor, one wire goes to the one side and the other wire goes to the other. Servo, we're going to look at servo later. And stepper, we're not going to use that today, so that doesn't matter. So I want to look at just the AF DC motor, and it says here, label that port number 2 motor. And so every time it says motor, we're talking about using port 2 on the motor shield. And so here it says void loop, so this is the loop function. Oh, we got a motor, set speed to 200. So this is, it's able to set the speeds between 0, which is off, and 255. So from 0 to 255 is what it allows you to use. 200 is pretty fast. So it says set the motor speed to this. This makes sure that it's off. And then it says set the motor to run forward. You can either have forward or backward in here. And so it says run. It doesn't do anything at this point. It could. It actually runs at 200, but only till it gets here. And that's so fast it doesn't matter. So this is servo 1, right I. That's servo 1. We're not using the servo, so that doesn't matter. This says motor, okay, and that we are using. We're using motor. Motor is set to port 2 on the motor shield. And it says set speed I. The first time through this for loop, for I equals 0, the speed is equal to 0. It won't run. The second, it delays for 3. The second time through, it's set to 2, 3, 4, 5, 6. And it keeps going until the motor starts going. This delay 3 is necessary for the servo, but without it, it'll run so fast that you won't even see it. There needs to be some sort of delay in there, or you'll just keep increasing the speed. It will look like it's at 255 right away. So you need a delay in there. And this says for I equals 255, start at 255. Well, this is a question we have. What does the I++ mean? This is identical to this statement, I equals I plus 1. It's just an abbreviation for it. So you can either write I equals I plus 1 or you can write I plus plus. They mean the same thing. Same thing happens here. I minus minus is the same as I equals I minus 1. So here it starts at 255 and it decreases each time through this for loop until it gets to I. This says I is not equal to 0. When I is equal to 0, it pops out of this loop. Okay. And then it does the same thing except it runs the motor backwards. So I wanted to simplify this and just have it work for motors. So I pulled all the code out of there and I wrote my own version. And here it says Adafruit Motor Shield Library, copyright Adafruit 2009. This code is in the public domain. Enjoy. This code has been modified by me. Now it's not cheating in terms of this class. And this is a note so I can keep track of things. Adafruit has a number of versions of their Motor Shield. And I wanted to make sure that I was clear which one we were using. So we've got the same thing. It says include AF motor. This time I've also decided to put in the servo too. So I'm including the servo. And I'm saying AF DC motor. This calls a function. I say make there be a DC motor. Set up port 4 on the motor shield to be a DC motor called motor LF, left front. Okay. Then I do the same thing on the motor shield port 3. I call it motor right front. And so now I've got two motors I can use on the front of a car, right? And I could do one on port 1 and port 2, and it was in the original program. I left it here with comments just so I would remember that you can also do this for two other DC motors. Then it says set up a servo and call it servo 1. This library works a little different. You don't tell it what port to use here, but that Arduino program I was looking at does show you how to do it. And then I decided that I needed a slowest speed for the motors because they don't turn on when the speed is 0 or 10 or 20 or 30. With 5 volts going in, they don't turn on. And then I wanted to have a way I could change the speed in the whole program pretty quickly. So I put in a variable for that and called it length. It's really length of time. So I've set up the serial port and I have it print line motor test. You could cut that out if you wanted. And then this sentence sets up which port, really which pin is being used to control the servo. And right now it's on pin 9. And I'll show you where to plug in your servo for pin 9, but you could just plug in the ground and the positive to the ground and the positive on your board, and then the control, the center pin on the servo connector to pin 9, and it would work. There's an easier way to do it. So now it says set the speed for the left front motor to 0. This is just to make sure it's at 0. Set the speed for the right front motor at 0 and release them, turn them off. Left front and right front. I'm using these comments to break up sections of code because I find it makes it easier. you are going to run into this gobbledygook, and so I thought I should explain it. I don't really want to use it, but it's in the example code, so we have to know what it means. When a variable declaration starts with a U, it means unsigned. That means positive numbers only. And then this says int, which is integer, and then it says 8. And I don't know what the underscore T means, but this means 8-bit. So normally our integers are stored in 16-bit variables, so this is smaller. So what this says is unsigned 8-bit integer, and so that means it's only positive numbers and only between 0 and 255. It's perfect for setting a pulse width modulated speed. It uses no extra memory, but it adds a complication to things. So I am going to continue to use just integers for that. But don't be surprised if it shows up again in example code somewhere. So I just want to tell the serial port that we're going forward so we can check and see whether or not the motors are really going forward or not. So I set them both to forward. I could also set them to backwards, right? Notice that this is all capital letters and comes out in blue. And then I have a for loop, and it's got I. I is equal to the slowest speed. Remember, we defined that as 130, and that was what was working on my motors. So it keeps going so long as I is less than 255. I equals I plus 1. So each time through this loop, it gets higher and higher and higher. And it sets the speed here. So it was at 130. And here, this one is at 130. So they both should run forward and then slowly increase in speed and delay length. And this is 8 microseconds. Length was 8. Let's go up and check. Length equals 8. Great. So let's just make sure we're looking at the right things. There's the beginning squiggle and the end squiggle. Here's the next one, beginning squiggle and end squiggle. This says start at 255. Do it so long as I is greater than the slowest speed, greater than 130, and each time through subtract 1. This is the same as I equals I minus 1. Then when you get done, delay for 50 microseconds. And then it goes through, it does exactly the same thing, except that this time through, the motors are set to run backwards. Okay. And then the motors turn off by releasing. Then there's a delay of a whole second. And then we test the servo. And it says for I equals 0, I is less than 255, I plus plus. Servo right. Send a pulse width modulated signal of I is what this really does to the servo control pin, which is pin 9. And then just like the other one, it starts at 255 and goes down to 0 this time. And these are roughly angles, but as I understand it, this only goes up to 180. I have not tested that yet, and it depends on the servo motor. So I'm going to plug in my my board. I'm going to go under Tools, make sure that I got the right port selected. Then I'm going to load it up. And then I'm going to bring up something where you can see. can hear them already. Oh, I don't have the servo motor plugged in. Here's the two motors, forwards and backwards. And if we want, we can bring up the serial port. So this should be forwards coming up and then backwards. And if they're not going in the right direction, all you have to do is switch the two wires for that motor. Okay, now, I never remember which servo port. Oh, where's my... Here it is. I never remember which servo port to plug this into. So if you look right here, there's these 6 pins. There's 2 sets of 3. And on the end of your servo motor, here's the servo motor, there's this plug. The brown wire is usually the ground, and it is on the outside of the board. So I'm going to plug that in. Right now it's not working. So I've got it in the wrong port. Okay, so the next time through we'll see it. And there's the servo motor. So that's how this thing goes. And if you're using these little servo things, there's a limit to how big a servo motor you can hook up to that. But these little ones work fine on it. They are fragile. These are not the best servo motors in the world. They are the cheapest servo motors in the world. So don't try to get them to do too much. And there it is. And so if there's a part of the code that you don't understand, let me unplug this so it's not making noise. There are a couple of ways to get help. One is to ask me. One is to ask somebody else. And another is to slowly go through this MotorShield tutorial. So the original Adafruit version was a kit that you had to solder together. And so maybe you can skip the make it, but there might be some information in there. And then there's the use it. And then you can look at the Adafruit software and see if there are enough comments in there to make it make sense. It is not particularly well commented. If you want to run your servo by itself, I'll give it a second. While you are sending things to the serial port, things can be really slow too. I have a hard time getting my Arduino software. It does not quickly turn back to the Finder. But if you look at this and you go down, you're looking for the servo library under examples. You go to servo library. This sweep program, and we're waiting for it to open up now. Hopefully it will. Maybe I did select it. Yeah, da 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 da. Maybe I got too much open today. Okay, here's the sweep function. This is nicely documented. So this says servo. It says create a servo object to control a servo. That object is called my servo. It says 12 servo objects can be created on most boards. This was news to me. POS, that's position, equals 0. It says attach it to pin 9. And this says that it's going to turn in degrees. And this is not always true, but it looks like it might be true with our servo motor. And so it says write to that pin position. And in this case, it's a pulse width modulated signal of 1. And then delay for 15. On servo motors, if you don't put in a delay, if you tell the servo motor to go someplace and it has not gotten there before you send another command, your servo motor can get confused and it can get goofed up. Not broken, just not operate right with your program. So you want to always make sure that there is a delay, and it depends how far you're going to move it. The further you have to move that servo motor, the more time you need to give it. So I'm going to plug this back into my Arduino. And I'm going to plug in my USB cord. And then I'm going to upload this piece of software. And you can, I got to turn on the video. There we go. And so you can see it go again. But if you want, we can go back into this software. This is another way to say that. We're going to change this, and we're going to send it up, and we'll see that it goes in one direction quicker. And there's enough time there for it to get all the way. There we go. So you can have it move quicker than it is in this example, but you do have to make sure that there's enough milliseconds wait between things in order for it to get there. And if you didn't want to use a for loop, we can get rid of this. And we can get rid of this. Well, let's leave the delay in there. And let's write it to 130, because I know that'll work. And let's delay. Let's make sure we have enough time. This is way more time than we need. And let's load that up and see what it does. It should move really quick to 130. There it goes. So you can see it. It'll move pretty quick. Okay, so I think that is the end of this.